All right, good morning. So today we're going to continue our look at acceleration and force and how to actually solve mathematically questions of force and acceleration. So this is going to be related directly to Newton's second law, which we refer to as the law of acceleration. And it basically deals with change in motion. So just a quick review, just to make sure we're clear on some of these terms. So a balanced force is a force that, and actually before we even get into this, you want to have your worksheet out for the for the exit ticket lesson, so that you can kind of fill this out as you go, as you watch this video. So we can say that a balanced force is a force that has an equal and opposite force. So you would fill in on the blank line the phrase has an equal and opposite force. So that's what a balanced force is. Okay. Next, it says an unbalanced force is a force that is not canceled out. It's a force that is not canceled out. So unlike a balanced force where the two forces work opposite and basically cancel each other out, an unbalanced force is a force that is not canceled out, and it's a force also that makes something accelerate. We don't want to say, we could say move too, but accelerate is the proper term to use there, because accelerate can refer to a motion speeding up or increasing in speed. It can also indicate that movement is slowing down. Okay, so we'll just use accelerate as the official proper term there. Okay, and Newton's second law, so let's get out of the review and into the second law of motion, the law of acceleration. Newton's second law basically tells us that the forces acting on an object equals the object's mass times its acceleration. So force is a mathematical equation. So the equation that we use when we're solving for Newton's second law is force equals mass times acceleration, or F equals ma. It's another way to write that. So you want to write this down too. Force equals mass times acceleration. Now the formal definition that we're given for the second law of motion is that acceleration is directly proportional to net force and is indirectly proportional to mass. Therefore, an object will accelerate in the same direction as the net force acting upon it. So that's the formal definition. You want to make sure that you have that on your paper somewhere if it isn't already there. And sorry I keep drinking, but it's very dry in here today in this building. Okay, so blank is an acceleration force. It's a constant, and on Earth it's equivalent to 9.80 meters per second squared. Does anybody know what this acceleration force is? We've talked about this force before. One of the first forces formed in the universe, we think. It is gravity. So if you said gravity, you were correct. You can make sure you populate that on your worksheet. You will encounter gravity as an acceleration force at some point in some question somewhere. You just have to remember that if gravity is the force acting upon it, then acceleration is equal to 9.8 meters per second squared. All right, so let's talk about a question here on your sheet. The question says this. You have two shopping carts. One's empty, one is full of groceries. You push both of them with the same amount of force. Which one, that's a typo, which one has greater acceleration? I'll give you a moment to think about that if you need to pause the video here to give it some thought. Go ahead and do that. Okay, so the answer to which one has greater acceleration is the empty cart. Why? Why is the empty cart going to have more acceleration with the same amount of force applied to it as the full cart? Well, it's because it has the same amount of force, but the mass is lower. Mass is lower. So if you do the math on that, if you just make up an amount of force, like 9.80, and you let's do that. So if F equals ma, and we want to know the acceleration, we have to basically divide m from both sides to get rid of the m on this side. So now we have F divided by m equals a, which we can flip around to a equals F divided by m. It doesn't really matter if it's on the left or the right, that's irrelevant. So let's write it down again. A equals F divided by m. So if we make up some forces, we're going to use, let's say, F equals 9.8. That's gravity, but we'll say we put as much force on the cart as gravity is putting on it. Okay, and let's say our mass of the empty cart was 20 kilograms. If we work that out, we get, I would need a calculator, I don't have one. So basically 9.8 divided by 20, whereas our other cart would have the same amount of force, 9.8, say, versus 9.8 divided by, let's say the full cart is 60 kilograms. Well, you can tell just by the numbers that 9.8 divided up into 60 slices is going to be very small, right? Each slice is going to be very small. So its acceleration is going to be very small. But 20 goes into 9.8. You get 20 slices of 9.8. Those slices are going to be bigger, right? So your acceleration is going to be greater. It's going to be bigger on the empty cart than it would be on the full cart over here. Okay. So let's look at the guided practice, and then the lesson that goes along with this has another worksheet in it that has some similar problems in it, but we're going to do 4 problems here together. So the question statement is, if a 10 kilogram object accelerates at 3 meters per second squared, what is, there's another typo, is the force on the object? So let's first figure out what we know and what we don't know. And we do that all over here. What do we know? What does the problem tell us? What doesn't it tell us? Well, it doesn't tell us the force. That's what we're trying to solve for. So some question marks there. Our mass, we're going to look for the kg, right? That's indicating a measurement of mass. So mass is 10 kilograms. Then acceleration always has the unit of meters per second squared. So we find the number that is the meters per second squared, and that's 3. So we put that next to the a. Now we know all of our variables. Now we just need to solve for the problem. So we know that our formula is F equals m times a. So we're going to just put this down here just so we remember it, right? M times a. Okay, so if the first one is m, if this is m, then we need to bring up our m, which is 10 kilograms, and then we need to bring up our acceleration, our a, bring that up from here, and that is 3 meters per second squared. And then you see that we just multiply those together. See the x there? Multiplication symbol. So 10 times 3 equals 30 newtons. So our final answer is the force which is always measured in newtons, by the way, is N. So you might wonder, well, what is N exactly anyway? Well, N is equivalent to kg times m divided by s squared. So that's kind of a very long thing. So instead of putting, let me get a little different here. Instead of putting n here, we could put kg times m divided by s2. But that's a whole lot of writing stuff. We can just represent this amount, or this unit, as being N, Newton. It's named after Isaac Newton. So it's just a little easier to write. But algebraically speaking, it is the same as multiplying these together. So if these were both 1 kg times 1 m divided by s2, you'd end up with 1 kg m over s2. You can cancel those out, really. They're kind of inferred. So that's all we're doing. It's just pure algebra. Alright, let's move on to guided practice number 2. If a net force of 3N acts on a 3 kilogram cart, how quickly will the cart accelerate? Well, let's first figure out what we know over here. What do we know? We know that force is 3N. So here that is right here, 3N. Okay, we also know that we have a mass here, a 3 kilogram cart. That's mass. So that's going to go down here for mass. And notice we're working with the A divided by F over M in this case, just like before, like we talked about before. So A is what we're trying to figure out, so we'll just put some question marks there. So now we know what we know, and now we know what we don't know. So let's just plug in the numbers into our formula, and we get, oh, by the way, here's a copy of our formula. A divided by F, A equals F divided by M. So we got our kilograms first, so this is going to be our M, but that's incorrect. That should be not that. These are backwards, so look at that. It'll work out the same in this particular case, but you have to be very careful to get these in the right order. So this really should be newtons, and this should be kilograms. Okay, so don't make that mistake. This is very important. In fact, this isn't an accidental typo. I put it in there on purpose so that we could correct it, so that you would see that it does matter where you put each of your variables. Now, because they're the same number, it's not, it would come out the same, because 3 divided by 3 and 3 divided by 3 is always going to be 1. So now we just do the division, and notice that we've got a division number, a division symbol. We're not multiplying this time, we're dividing. Remember, our formula is A equals force divided by M, and of course the lawn maintenance guys have to bring 3 leaf blowers in the middle of the winter right up past the window while I'm trying to record a lesson. How fun? How fun is that? Alright, so let's do the division. 3 divided by 3 equals 1, so that gives us 1 meter per second squared as our answer. So the acceleration, the rate at which this object accelerates, the cart, is 1 meter per second squared. Alright, here's guided practice number 3. If a ball accelerates at 2 meters per second squared and a net force of 8N is acting on it, what is the mass? Well, let's solve for, well, first, as always, let's figure out what do we know and what we don't know. Well, we know that we've got 8 newtons. 8 and 8. And we also know that we've got to solve for mass. We're not given mass in the problem, but we are given the acceleration, which is 2 meters per second squared. You see it here, so we'll put it down here. And now, what is our formula going to be? Well, you're kind of given a hint here. It's got to be mass first. So if we do F equals the one that we know, ma. We need to get m by itself, so we have to divide by a. Divide by a. That cancels out the a's over here. Leaves us with m equals f divided by a. So there it is. M equals F divided by A. So I just flipped it back around, put M on the left side of the equation, which is fine. Now we can plug in our numbers. So our 8n needs to go here in the first spot, 8n, and our 2ms needs to go in the second spot. And then we can do the division. 8 divided by 2 equals 4 kilograms. Now notice my unit is kilograms here, right? Mass is always going to use grams as its base unit, in this case kilograms. So we're using kilograms. Okay, makes sense? All right, let's move on to the fourth and final. This is kind of, we don't have to do math on this one. We just have to think. So if we use the same force to throw a bowling ball, a tennis ball, and an elephant, which one would accelerate the most? And why? So which one would accelerate the most? Take a minute to think about that. Press pause if you want to. But here comes the answer. All right, if you said the tennis ball would have the most acceleration, you would be correct, and that is because it has the lowest mass. It's going to result in the fastest acceleration. Alright, so here is the exit ticket for today. You're going to finish the recap of Newton's laws, that table at the end of your worksheet, and you'll submit the entire worksheet completed. You need to have the whole thing completed. I will be grading the whole thing, but your exit ticket, the thing you're going to do on your own, is finishing that recap of Newton's laws table at the end of the worksheet. You also have another lesson to work on, which has some problems similar to the 3 that we just did together. And if you have any questions or get stuck, please, 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 please don't spend hours trying to figure it out on your own. If you're stuck for more than 5 minutes, you need to call me or email me or send me a Schoology message so that I can help you and you don't waste as much time trying to figure it out on your own and getting nowhere. Okay? So don't spin your wheels. Take advantage of your resources, and I should be your #1 resource. All right? That's it for today. Thank you, guys. Bye.